Hello, welcome to another Secondary 2 math video. I'm Mr. Green. I'm a teacher here at Mountain View for those that don't know me. Um, for my students, it's good to see you all again. I can't actually see you, but I'm imagining your smiling faces in my classroom. I just got the news that the at least in-class portion of school is canceled till May, which I'm really sad about because I won't get to see all of you until May at least, and hopefully we will come back to school before the end of the year. This is crazy. I hope you're all staying safe, being careful out there. It's a scary time for sure. And it can be crazy to kind of try and have to keep up with school stuff, even with all this going on out in the world. Um, Make sure you do take care of yourself. Let me know if you need extensions, and I'll work with you on those things as they come up. Mostly just try and keep up with the stuff that we're doing. Um, and it'll make it so that when we do come back, hopefully we come back, you'll be more caught up on things. Um, so today what we're going to be doing is dealing with square roots. And I don't think this is too much harder than what we've been doing before. It's very similar to what we've been doing before. It's just a different type of graph than the other ones that we've dealt with so far. Last time we dealt with absolute values, which remember are the V shape, right? They have the V shape. Parabolas are the U shape. Those have x squareds in them. Absolute values have the bars in them, right? The two bars. So what we're going to be dealing with today are square roots. And kind of our goal with this is I want you to be able to draw a graph of square root functions. As well, I want you to be able to draw graphs and write equations for transformations of square root functions, okay? So that's when you're shifting it left or right, up and down, stretching it. That's what we're going to be doing today, okay? So just a reminder, kind of our notation with square roots. We use this symbol here. This means a square root, right? And so for instance, like the square root of some number, 9, for instance, is equal to, well, it's the number that you have to square to get this number. So what number, when you square it, do you get 9? It is 3, okay? So the square root of 9 is equal to 3. And we've dealt a lot with square roots in this class, right? We've used them to solve quadratics, to get rid of squares, essentially, right? And so today what we're going to just be looking at is what does it look like when you have a square root inside of a function and you're trying to graph what that function looks like, okay? So let's look at what does it look like when you graph f of x is equal to the square root of x. What does that look like? Okay, so remember this is like my y. These are my y values, and then this is my x. So whenever I put in an x, I'm just taking the square root of it to get my y. I want to draw a graph for what this will look like. So let's do kind of a table here. This will be x and y, right? So let's start with maybe plugging in x equals 0 into this equation and see what we get, okay? So when I do x equals 0, everywhere there's an x in this equation, I'm just putting a 0, right? So my answer for y here is just going to be the square root of 0, which the square root of 0 is just 0 because 0 squared is equal to 0. Okay? Throw that in the calculator if you're not sure. The square root of 0 is 0. Okay? So we're going to be at the point when x is 0, y is 0. So x is 0 is here, y is 0 is here. So we're just here at the origin, the point 0, 0. Okay? Let's plug in another value. Let's plug in positive 1. Okay? So positive 1 for my x value is here. Now we just want to figure out what y value am I going to be at. Well, I replace, go back to my equation, everywhere there's an x, I put a 1, right? So I put a 1 here, I get the square root of 1, which is 1, right? 1 squared is 1, so the square root of 1 is 1, okay? So when I plug in 1, I get 1 out. Okay, so I'm at the point 1, 1. Okay? Let's do something else. Let's do maybe 2. Okay? So let's plug in 2 into this. What happens when I plug 2 in? I get the square root of 2, which, this is maybe not the best thing to plug in, right? Because the square root of 2 is a nasty number. In fact, let me throw it in the calculator here so that we remember what this is. We'll do the square root of 2. And this is about 1.41, and then it keeps going 428. It's a really long, nasty decimal, okay? And so this is maybe not the best x to plug in because you get a nasty number here. Still, I'll just kind of estimate what it is. At 2, at x equals 2, we're at 1.4. So we'll say that's 2, about 1.5-ish. Maybe like right in there, okay? Now, I would kind of like to not get decimals here, right? It would be a little bit better if I didn't have to worry about decimals. So, are there any numbers we could plug in so that I would get a nice number out? Well, I'm going to be taking the square root of whatever number I plug in, so what could I plug in that has a nice square root? In other words, that's a perfect square. Well, 4 is our next perfect square, right? It's 2 squared, okay? So when I plug that in, I get the square root of 4, which is 2. Okay, so that tells me over here at 4, 1, 2, 3, 4 for x, I get out a y value of 2. Okay. Now from this, you can kind of tell what this graph is going to look like just by plotting these points. I'm going to look at a few other things too. We've only plugged in 0 and positive numbers, okay? Let's plug in a negative number, okay? So let's do like -1, so like right over here. So what happens when you plug in -1? You get the square root of -1. And what happens with that? Do you remember? The square root of a negative number doesn't exist, right? If you try and throw that in the calculator, it will say error. In fact, we had a special name for this number, okay? We said that this was I. This was an imaginary number, okay? So, but I isn't a real number, so we can't see it here on our y-axis. So this one, this does not exist. Okay? This doesn't exist when we plug it in. So that means there's no points over here. There's no points on the left-hand side of my graph. And so that means that only this stuff is going to be in my graph. It's going to look like this. Okay? And it's a curvy line. It's not a straight line. Okay? It's kind of curvy. In fact, what does this look like? Well, it kind of looks like a parabola. It's just it's on its side. Instead of being a U, it's kind of like sideways parabola. Okay? But it's only half of a sideways parabola. Okay? And in fact, that is the shape that it is. It's really half of a parabola laying on its side. Okay? So this is our graph of just the x squared function, or sorry, the square root function without any transformations done to it. It just looks like this sideways parabola, okay? Just half of a sideways parabola. Okay. So we're going to be using this to sketch some other graphs as well. And so what we're going to be looking at is transformed versions of the square root function, okay? So that means I'm going to start with this one, just the square root of x, and when I start throwing numbers inside of that equation with the x, a, h, and k are all numbers, we wonder what happens to our graph. Well, A, this is going to stretch things out, okay? This is kind of like in our vertex form of a parabola, we had something like this, right? And the number in front of the square, this stretched things, made them wider or tighter, right? So this is your vertical stretch. If negative, it flips upside down. I'll show an example of that later, okay? But if you have a negative in front, right, kind of like what we did with parabolas, it would make, instead of the parabola being a U shape, it would flip it upside down, okay? The h that's inside the square root with the x, okay, that moved us left and right, okay? And it did the opposite of what the sign was. In this case, where I have a minus with the h, I'm going to be going to the right h, okay? I'm going to be moving to the right, okay? And then the k on the outside of the square root, that tells me I'm going to be moving up and down. The number on the outside of the function, that moves us up and down. In this case, since it's a plus, we're going to be, we're going to be moving up. Okay. Okay? So let me show you an example of this, okay? So we have a square root function here. Y equals the square root of x plus 4 minus 1, okay? So we need to figure out what's happening with our transformations here to give us a new graph, okay? So first of all, this plus 4 here with the x, what is that going to do to our graph? Well, the plus 4, where it's next to the x, is going to do the opposite of what we would think it would do. It's going to, instead of moving us right 4, this moves us left 4. And this, the -1 on the outside, that does what we think it would do. We would go down 1. Okay? So, my regular square root graph, let's remind ourselves what it looks like. It's a sideways parabola. Okay? So, it starts at 0, 0. At 1, it's 1. And at 4, it's 2. So, it looks like that. Okay? This is the square root of x. Okay? Without any transformations done to it. Okay? Let me make these points bigger so that you can see them. Okay? So what happens with this graph? I go left 4. So I'm going to go 1, 2, 3, 4. And then down 1. Down 1. Okay? And so this point here is going to move over to here. Okay? But then the shape of the graph is going to be exactly the same. Okay? So you'll notice on this one, you went over 1, up 1, right? So on this one, you're also going to go over 1, up 1. Okay? And then to get another point, we went over 4, up 2. So I would also go over 1, 2, 3, 4, and up 2. So this would be our new graph of the function. Okay? This is what this equation would give us when we graph it. Okay? So essentially, we're just moving our square root graph around. Okay? Let's do the same with this one. So the graph I have is y equals the square root of x, okay, minus 2. Okay? Notice there is nothing inside the square root with the x. Okay? There's nothing underneath the square root with the x, right? On this one, we had a 4 inside the square root with the x. In this one, there's nothing in there. So this tells me I'm not going to move to the left or right at all. But this 2 here, this minus 2, means I'm going to be going down 2. Okay? So let's look at a graph here. My regular square root graph, let's do that again. It starts at 0, 0. At 1, it's 1. At 4, it's 2. Okay? So it looks like that. That's our regular square root of x graph. Now what will happen with this? It will just go down 2. So it won't go left or right at all because there isn't anything inside the square root. It will just go down 2, and then it will have the same shape. It will go over 1, up 1, over 4, 1, 2, 3, 4, and up 2. This would be the graph of our square root function. Okay? So you don't have to have your square root function in your final answer here, but I think it kind of helps to start by sketching your square root graph so that you can just do the transformations to it. Okay? A few more examples I want to look at real fast is what happens when you throw an a in front, okay? So in this one I have a 3 times the square root of x, okay? And I want to know what that looks like, okay? Well, my regular square root graph looks like, we'll sketch it again, at 0 it's 0, at 1 it's 1, at 4 it's 2. Okay, that's our square root graph. Okay, when I times by a 3 in front, what is going to happen? All of the numbers, all of the y values are going to get 3 times bigger. Okay, so at 0, I was at 0. Y was 0. Timesing that by 3, I would still be at 0. Okay? But what about at 1? When I do 1, right, y is 1 here, times 3 is going to put me up at 3. 1 times 3 is 3. So 1, 2, 3 is where I'm going to be. Okay? At 4, I was at 2, but then I'm timesing that by 3. So I would actually end up at 6. 2 times 3 is 6. So 1, 2, 3, 4, 5, 6. Okay. So you'll notice this is what this graph would look like. Okay? So it stretches it out and makes it kind of like the parabola becomes wider in this case. The half parabola becomes wider. Okay? So let's do one last example with a combination of all of these things going on. Okay? So I've got here 1 minus 2 times the square root of x plus 6. Okay? Well, the 6 is inside the square root with the x, so that tells me right and left which way I'm going to go. Okay? So where it's a plus, I do the opposite. I go left 6. Okay? Now, what does the 2 do? It's timesing by the square root. So this is a stretch. And that doubles all my y values. Okay? The negative, this negative here, this means it's going to be upside down. Oops, sorry, let me rewrite that. This is upside down. Okay, so the negative in front means we're going to be upside down what we were normally. And then this 1 here, that's just adding to the rest of it, right? So that, normally we've been writing that over here, but it doesn't matter what order you write it in. This will still be up 1, okay? So let's sketch our regular graph of square root and do all these things to it. This is a lot, right? I start at 0, 0. At 1, I'm 1. At 4, I'm 2. So this is my square root graph. Okay? Now what am I going to do? Tells me I go left 6 and up 1. So left 6, 1, 2, 3, 4, 5, 6. And then up 1 is going to put me right there. Okay? So now what I would be thinking of to get my actual graph here, it's not going to be the exact same shape as this one because we've got this stretch and flip going on. Okay? So normally with my square root graph, when I go over 1 from this point, I would go up 1, right? But in this case, since I have a negative 2 in front, when I go over 1, instead of going up 1, I'm going to times that up 1 by negative 2. And so I'm going to go down 2. Okay? So Normally when I go over 1, I go up 1. So this -2 will mean when I go over 1, I will go down 2. Okay? And then to get another point, I could just plug in a number for x to get more points along this. But I guess I could figure out another point by noting when I go over 4 from this one, right, I go up 2. Okay? When I go over 4, I go up 2. Over 4, up 2. Okay? So if I go over 4 in this one, 1, 2, 3, 4, what am I going to have to do? I don't go up 2 anymore. I would take that 2 and times it by the -2. Okay? So -2 times 2 is -4. And so instead of going up 2, I'm going to go down 4. So 1, 2, 3, 4. So my new graph looks something like that. Okay. So it's just an upside down square root graph. It's kind of like the other half of the square root. Okay. Hopefully this is starting to sink in. This one was complicated, right? There was a lot going on with this one. A lot of transformations. We had 1, 2, 3, 4 transformations. But that's about as complicated as it can get. Okay, last thing I just want to mention here before we're done is, let's say they give you the graph of a square root and they want you to write the equation. Okay? So we have a graph here of a square root. You'll notice that it looks like a regular square root graph, because regular square root starts at 0. When you go over 1, it goes up 1. When you go over 4, it goes up 2. Okay, so that's our graph here. Okay. Well, what happened to get between these two? I went 1, 2, 3, 4, 5. Went down 5. Went down 5. Okay, so how do we write that in our equation? Here, let's change our color so we don't get confused here. Down 5. Okay, so from here to here, I went down 5. So in order to get that to work in my equation, what I just need to do is, my regular equation is the square root of x. I'm not moving it left or right, so I don't need to put anything inside the square root. Okay? But I do move it down, so I need to put something on the outside of the square root. And since I moved it down 5, I would do -5 on the outside. Okay? So this would be f of x, would be the square root of x minus 5. Okay? Let's do a similar one now for this other graph. So my regular square root starts at 0, 0, goes over 1, up 1, over 4, up 2. There we go. There's our square root. Regular square root graph without any transformations. So what happened between this graph and this graph? Well, it looks like, so this point moved to this point. So I went left 2, and then down 2 to get between these two parabolas. Well, sideways halves of parabolas, right? So we went left 2, 1, 2, and then down 1, 2, okay? So to get our equation for this red line here, the equation of it would be, well, there's for sure going to be a square root of x in it, okay? I moved it left 2, okay? So what does that mean? I need the left and right goes inside with the x, okay? And I switch the sign when it's right next to the x. So instead of being a minus, it's going to be a +2, right? To get me to move to the left. And then, sorry, let me rewrite this. X + 2. I need to switch the sign on the 2 because left and right does opposite of what I think it would do. And then down 2, I don't switch the sign there. It would be a -2. So the square root of x + 2 and then -2. Okay? So this is the down 2. This is the left or right 2. So this is left 2. This is down 2. Okay? So those are our equations for these square root functions. So hopefully this is starting to make sense. You'll go ahead and do the homework for this lesson. That should give you some good practice. And then take the quiz about graphing square root functions. Okay? I hope you have a good one. Stay safe out there. I love and miss all of you. I look forward to seeing you soon, hopefully. We'll just cross our fingers, wash our hands a bunch, use hand sanitizer. We'll get there, okay? We'll see ya.